What's up, guys? It's Chase from Chase's Workshop, and this is going to be a Chase Talks episode about some things I've got going on in the shop. The one thing I want to start with is I know a lot of you guys have been wanting me to make these B-bender parts for you, and I've been working on that for like 2 weeks now, trying to get the process down, and I've had 3 failures, and then I've had 1 successful part, but I would say it was probably 98% successful. What I'm running into here is I've got a CNC machine that's got a DeWalt router on it, and I don't know if you know anything about routers and stuff, but those are great at high speeds, but when you get down to a lower speed trying to cut aluminum, your amps drop on the machine or drop on the router, and it doesn't cut as good. And if you go too fast, you're building up too much heat, and you can't get the chips out. And it's a huge ordeal trying to get a router to cut aluminum. So, but basically what I've been doing is, and I'm going to go through this part here first. This was my first failure, as you can see that there. Now, what I've been doing is that this is my end mill. The old way I've done them, and the one successful one that I made, that I worked, and I did it this way, and I just basically slotted it. And what I mean by that is I had this bit, when it's cutting, it would drop down 10,000ths of an inch, and then it would make a contour of the whole part. And then it would drop down 10,000ths and do the same thing. And just kept doing that all the way till it got to the bottom, and then you had your part, basically. And it worked. It worked great with a sharp bit. Now, the bit wore out after 2 millings, 2 of those trying to make one. So I made 1 successful one that I've had in my guitar, then I made 1 other successful one. And then my bit got dull. It's the only thing I can figure. It got dull, and it started doing this. Now, the reason it's getting dull is because with that type of machining, basically I'm eating up the tip and 10,000ths of this bit. Now, as you can tell, I've got all this other area right here. Now, the bit I'm using is a little bit shorter than this one. It's a 1/2 inch, so it's only about there, but I'm only using the very tip of it. So I'm wasting all of this extra stuff here. Now, I did the same thing for the next one. I got to this part here, and a lot of this one too was my fault. And what had happened is I got all this part milled out, and then when I started here, the bit was dull. I had cut down the RPMs to try to slow it down to where it wasn't building up so much heat, and it ended up eating into the side. When it did, it broke this loose from the way I had it held down with the double-sided tape and all that stuff. So this part got messed up too. Well, after doing a ton of research online, I found a guy on YouTube. It's actually the name of the channel is NYC CNC, and very cool channel, man. They've got all kinds of stuff. They use Fusion 360 like I do, and I mean, I haven't found a bad video on there yet. And the guy seems like a really cool guy too. His name's John, but he said, and what he was saying is that stop slotting your parts and start using what's known as a high efficiency milling, and short for that is HEM, is what they call it. And basically what that is instead of using just the very tip of your bit and 10,000ths here, use all of this area and take the material from the side. And basically what I mean by that is that when this thing is milling, instead of doing a 10,000ths drop and going all the way around the part, 10,000ths all the way around, you're going down to your quarter depth, which is that there, and basically you're eating the side like that. And this thing will sit here, and it'll make a rotation like this and eat it that way. So instead of taking off 10,000ths this way, I'm taking off 10,000ths this way from the side. I'm going to put a video of it right here where you can see what I'm talking about. So, as you can see, all those parts there, I got it routed, and it was doing great, doing awesome. the biggest thing with milling aluminum is getting the chips out and keeping the heat down. And the only way you can really do that is to slow the RPMs. And with the router, I can't get below 16,000 RPMs. And so that was out of the question. And the only other way was to do what I did you just saw there. Now, I made this part, and this was the successful one. This was the 98% successful part. And if you're wondering about the 2% bad, it's that spot right there. So, what happened here? This part was going great. Everything looked great on it. I'm sitting there, and I guess I was getting bored. And the one thing I've learned about doing this stuff is do not touch anything. Just let the thing run. Have your finger close to the where you can shut it down if you need to, but other than that, don't touch it. Well, I couldn't do that. I was sitting there and this thing was routing. It was beautiful. It looked great. Well, I started noticing that aluminum chips were I was getting built up aluminum chips on my guide screws. What are they called? Crap, I can't even remember the name. Guide screws. You know what I'm talking about? The part that's actually where the machine's going. So I took a wire brush and I was going to scrape those parts off, and I don't know if static electricity or what happened, but the machine went into a limit switch, like the limit had switched out on it. So I took the part, and the last time I had that happen, and I just started back from where the point I was at, that's how that happened. So in my mind, I'm thinking, I'm not doing that, not going to happen. So I raised the end mill up, started it back, and of course it just went right back to where it was at, except for it was up here instead of down here where the part is. So I had to restart it, and what I done was I went down and I zeroed the end mill back down to where it was cutting out on the bottom down here for this bottom part. And I'll show you the part right here where I'm talking about what I'm talking about. Now, that part was zeroed to the bottom of the material at this point. When it got around to the side, it came around and it plunged down into the part, or down into the wood, and then came up, and it thought it had the clearance that it didn't, and it skimmed right across the top, and then I hit the switch to stop the machine right here. So basically I had to reset back to that last adaptive machining and let it run all the way back across here, back to that point. And it ended up working out though. So anyways, with this I've learned like 4 mistakes this whole time, but it's been fun. It's kind of been a headache, and kind of had I don't know, it's just been fun. Now, the other thing I want to talk about is the Pickup Winder 2.0. Now, I've had some issues, and I don't know exactly where that piece is. Here it is. This is what I basically come up with. I had the two parts, the Arduino boards mount right here and right here, and it was working, but I don't know if I've got a bad solder joint. I don't know if I've got what, but the Arduinos are doing some crazy stuff, and I don't know if I'm losing power or what. So I'm thinking that I'm going to end up just using what's known as a buck converter, and it's one of these little guys here, and they're not very expensive. They're like $2 or $3 I think on Amazon, but basically it's a lot more efficient, and you can adjust the voltage you want, and it does everything a lot better. Now I've also thought about just trying to maybe sacrifice one of my Arduino Nano boards to see if I can just plug 12 volts into it and see if it works. Now it says that it can go from anywhere from 4 volts to 4 to 14 volts. So I might just do that, and it might work perfectly. Any of you guys that are subscribed to my channel or watching this video, if you're I'm sure if you've played with Arduinos any amount of time, you're probably better at them than I am. So if you have any comments about that, just let me know too. I would like to know more about them than what I know now. But anyways, I've got that part. The only thing is the power supply. I've got to figure out what I'm going to do there. And like I said, I might just plug the 12 volts into it and see if it works. And if it does, good. If not, whatever. And I've got both of them done. I think you saw it in the last video where I had the setup with the RPM gauge and the counter too. So I got that going. The next thing I want to work on with it is I've got to figure out how all the mechanical parts of it are going to go. Like if I use a motor that's 3,000 RPMs, I'm going to have to slow that thing down to where, when it's actually adjustable, kind of, I guess. So I basically thought about mounting the shaft to where, you get the motor with the pulley to a shaft with a bigger pulley that can slow that motor down if I need to. Now I've got to get the motor here and mess around with it. And I've also thought about too, depending on how well the speed controller works for the motor, is to where maybe if I could just mount the motor in there and have a shaft coming out to where once it's all set up, I can just run it off just the motor by itself. And the reason I'm having to do that is because in order to get this opto interrupter switch to work, I've got to have some type of disc that's going to go through this thing to count. And I don't want this outside of the pickup winder next to where the bobbin's going to be, because if something hits it or whatever else, or gets dirty, or I don't know, whatever, you know what I'm saying. I want this inside the box. In order to do that, I've got to make the shaft longer or go with the whole rod that's going to be in there like that. So I'm going to get all those parts here and kind of mess around with it and see what I can do. I want to see how well this motor. Now, the motor I'm going to be using, one of the guys subscribed to the channel. I can't remember exactly who it is right now, but I'm going to put it in the description. He said, try this motor out, and I had never seen one. I've been searching motors for a while, and it looks like it would be really good. He said they're good. They're torquey, and they're fast. And then depending on what voltage you give them is how fast they are. So let me see if I can find who it is right quick. I don't know. I can't remember who it is. Whoever it was, I'm sorry, but I'm going to put it in the description down here, the motor that I'm talking about. Now, it's about a $25 motor, so it's a little more expensive than that one, but if it works for what we're wanting to do, I think it'll be better, I think. Thanks you guys for all the comments and stuff that y'all helped me out a bunch with different things and gave me different ideas, and basically have helped me do a lot of different things that I never would have done before, and I really appreciate all that. Coming up on 1 year of having this channel, and it's been fun. I enjoy doing it. I enjoy helping y'all, and I enjoy getting help from you guys too with everything that we are all trying to do here, and it's a lot of fun. I really appreciate it, and I appreciate all the new subscribers and stuff too. 2019 hopefully is going to be a good year for all of us, and hopefully everything that you want comes true, I hope. So guys, hope you enjoyed the video. If you do, give me a like. If you like it, please subscribe. Thanks for watching.